Hey guys, welcome to the last video in this Excel series focusing on data analysis, and we're going to cover multiple regression. And the only difference between a multiple regression and the regular regression is that there's more than one x value. There's more than one independent variable. So you can see very quickly how it's very similar. So in this example, we have you are a MBA student taking a statistics class, right? You have a final in 2 days, but there's a really awesome party tomorrow night. You've gathered some, previous data about a similar situation, and you want to do a little planning. You've gathered data about how many beers a person has had the night before the test, right? How many hours of sleep the guys got before the test, and how many coffees they drank the morning of the test. So those are your three independent variables, right? And then the dependent variable is, what the GPA is going to be on a 4.0 scale. So after you do the analysis, what might you do at this party, and so on and so forth, right? So I actually made the mistake of uploading the spreadsheet with the data already filled out when I sent it to the professor. So just work around it, pretend it's not there. And so here we have a data set of the GPA, right, that the previous guys got, and here is a data set of how many beers they drank the night before, how many hours of sleep they got the night before, and how much coffee they had the morning of. So in the process is pretty much exactly the same. You go to data analysis, you find regression, you hit OK, and you put the y range here, the dependent variable, as the GPA, because you're trying to predict the GPA, right? And instead of selecting one column for the x variable, you select all three columns. And I like my labels. Confidence level of 95% is good, and output range nearby, which is just going to go over the data I already have there. And once again, I want my line fit plots. Okay. So, this case is just saying, to overwrite the data that's already there, which you won't have, which you should also have, and you click OK, and there we go. It's exactly the same thing, only it gives you a couple of line plots. So I'm going to go to the answer section now, because I've already made the charts a little bit bigger, so we can easily see them in a minute. So here we have the R square of 0.96, which means that these three independent variables combined really does affect the GPA. There's very little error there, right? There's not that much that's not being explained by the three variables. The regression here is ridiculously, the F value is ridiculously high, and you can see here that the all of these, right, the coefficients for all of these different values, the y-intercept, beers by itself, sleep by itself, and coffee by itself, have a p-value that are all below 0.5, right? And the residual here output, based on observation number 1, which is 4 beers, 6 hours of sleep, and 2 coffees, you get a GPA of 3.5, so on and so forth. So let's look at the chart for a second here. So this is the chart for beer, right? So you can see that this guy had 1 beer and he got a 4.0 GPA. So you can actually have 1 beer the night before and still get a GPA of 4.0. And it's very true that the more beers you have, like this guy had 10 beers, the less, the more poorly you will potentially do on your test the next day. Once again, of course, all of this data has been made up, so don't actually rely on this data and to figure out how many beers you should drink the day before your stat final. So next one, we have the sleep chart, and I actually used a polynomial predictor for the data here to make it look a little bit more nicer here. And what it shows is that you don't want to have too much sleep. So 10 hours of sleep here in this example actually had a lower GPA than somebody who had between 8 or 9 hours of sleep. Right? So over here is kind of like a sweet spot. And you don't want to have too little, you don't have too much. And in coffee, same thing. 0 coffee, you might be a little, drowsy or whatever. If you have 1, maybe 2 coffee, you're gonna do okay because you're sharp. But if you have too much coffee, you start going downhill again, where you just you're too hyper or something. Once again, I use the polynomial predictor with the power of 3 just to give a better fitting line to see this idea. But even without the line, you can sort of see this trend, right? You can sort of see this trend that it's a sweet spot over here with 1 coffee, and everything else is not quite as good. So I interpreted the results here in the answer page, and you can compare your results and how you think about it. And that's pretty much it for this video series. And I'm going to leave you off with a little, fun. And this little dancing dude here will end the video series. All right? Have a good time in statistics, and I hope you guys do very well on your finals and midterms and so on and so forth. Have a good year. Bye-bye.